Before eyes, the world had no faces. There was light. There was dark. There was warm water. There were tiny living things moving through the ancient sea. But there was no seeing. Life could touch. Life could smell chemicals in the water. Life could feel pressure and movement, but it could not look ahead. It could not see danger coming. It could not watch prey escape. For a very long time, the living world was mostly blind. Then, something small changed. Some living things became sensitive to light. Not vision, not pictures, not eyes. Just a simple message. Light is here. Dark is there. That tiny difference may sound weak, but in evolution, tiny differences can become doors. A creature that could sense light could move toward safer water, or away from sunlight that harmed it, or toward the surface where food was easier to find. It still could not see another animal. It could not see a mouth. It could not see a shadow shaped like danger. But it had a clue. And that clue was enough. The story of your eyes did not begin with a perfect eyeball. It began with a patch. A small patch of cells that reacted when light touched them. Imagine a tiny animal in the sea. It has no face, no head like yours, no eyes. But one side of its body can tell light from dark. That is the first step. Not seeing the world, just noticing that the world has brightness. This mattered because light carries information. Light tells you where the surface is. It tells you when something passes above you. It tells you if you are hidden or exposed. A blind animal must wait for contact. It learns about danger when danger has already arrived. A light-sensitive animal gets a warning before touch. That is a huge change. At first, the warning was rough. A shadow might mean a predator, or a cloud, or a wave. But even a rough warning can save a life. If you move away from shadows more often than others do, you may survive more often. If you survive, you may leave more young. Evolution does not need a plan. It only needs small differences that matter. And light mattered. Over time, the flat patch changed. In some animals, it became a shallow cup. That sounds simple. It was not. A flat patch can tell light from dark, but it cannot tell where the light comes from very well. A cup can. If light enters from one side, one part of the cup is lit. If light enters from another side, another part is lit. Now the animal has direction. It still does not see a sharp picture, but it can tell that something is above, or beside it, or moving past. The world begins to have shape. This was a turning point. The animal is no longer only asking, "Is there light?" It can begin to ask, "Where is it?" That question changes behavior. Now a creature can turn. It can hide. It can chase. It can swim toward or away from a signal. A simple cup of light-sensitive cells can change how an animal moves through the world. Then the cup became deeper. A deeper cup makes direction clearer. A smaller opening makes the image sharper. Some simple animals today still show versions of this idea. They do not have eyes like ours, but they show how a patch can become a cup, and how a cup can begin to act like a tiny pinhole camera. No lens is needed at first, just a dark cup, a small opening, and cells that react to light. The image would be dim, it would be blurry, but it would be more than nothing, and more than nothing is where evolution often starts. Then came another step. A clear covering could protect the opening. If that covering bent light a little, It could also help focus the image. Over many generations, a better covering could become a simple lens. A lens gathers light. It helps make a clearer picture. It makes the world less blurry. Now the animal is not just sensing light. It is beginning to see objects. A shadow is no longer only a change in brightness. It can become a shape. A moving shape can mean food or danger. At this point, the story becomes bigger than eyes. Because once some animals could see, other animals had to change too. Before vision, you could hide by being still. You could survive by drifting. You could avoid danger by touch, smell, or chance. But when eyes improved, the ocean changed. Now movement could betray you. Body shape could betray you. Size could betray you. Predators could aim. Prey could flee earlier. The sea became a place of watching. Many scientists think this visual arms race may have helped drive the great burst of animal life in the Cambrian period, more than 500 million years ago. That idea is still discussed. It was probably not the only cause, but the timing is striking. Around this ancient time, animals became faster, harder, spikier, better at hunting, better at escaping. Eyes did not just help animals see the world. Eyes helped turn the world into a battlefield. One of the strangest ancient examples was the trilobite. Trilobites were sea animals with hard bodies. They crawled across ancient ocean floors for hundreds of millions of years. Many had compound eyes. Each eye was made of many tiny lenses, not one smooth window like yours. And here is the strange part. Some trilobite lenses were made from calcite. Calcite is a crystal-like mineral. It is also found in limestone. So in a real sense, some trilobites turned stone into sight. Their eyes were not human eyes. They were built in a different way. But they show the same truth. Once vision became useful, evolution built eyes again and again. It used whatever materials life had. Another ancient predator shows how powerful vision became. Anomalocaris was one of the great hunters of the Cambrian seas. It had a strange body. It had grasping front limbs. It had a round mouth. And it had large eyes. Those eyes were compound too. They may have helped it scan the water for prey. For an animal like this, seeing was not a small upgrade. It was a hunting tool. If you can see prey before prey touches you, you can attack from farther away. If prey can see you first, it can escape. Vision changed the rules for both sides. And that is the key point. Eyes did not appear because nature wanted beauty. They appeared because light could be used. Light could warn. Light could guide. Light could reveal another body before contact. That changed survival. But humans did not come from trilobites. We did not inherit their crystal eyes. Our eye story follows another branch. It goes back to very early animals related to the ancestors of backboned creatures. These animals were small, soft-bodied, simple compared with us. They lived in ancient seas long before humans, mammals, reptiles, or even true fish as we know them. Some of them had light-sensitive cells near the front of the body. That front end mattered. If an animal moves in one direction, the first part to meet the world is the front. So it helps to place sensors there. Smell near the front. Touch near the front. Light near the front. Over time, that front end became more important. It became the place where the animal gathered information. It became linked to nerves. It became linked to decisions. This is one reason heads exist. A head is not just a place for a face. It is a control center built around the direction of movement. Your eyes are on your head because your ancestors moved forward. They needed to know what was coming. That sounds obvious now, but it was a huge evolutionary idea. Do not wait for the world to hit you. Look ahead. The ancestors of vertebrates took this idea far. Their light-sensitive tissue became part of a camera-like eye, a cup, a lens, a dark lining, a nerve connection to the brain. Again, do not think of it as an eye appearing all at once. Think of it as a long chain of useful steps. A patch is useful. A cup is more useful. A deeper cup is more useful. A lens is more useful. Better focus is more useful. Better control of light is more useful. Each step can help a living animal. That is why eyes are not impossible. They look too complex when we start at the finished version, but evolution did not start there. It started with a tiny difference between light and dark. There is another strange part of the story. Many animals have eyes, but not all eyes came from one finished eye. An octopus has a camera-like eye too. It has a lens. It forms a clear image. It can watch. It can aim. It can judge the world. But an octopus did not inherit that eye from our fish ancestors. It belongs to a very different branch of life. Evolution found a similar answer twice. Actually, it found many answers. Insects built compound eyes. Spiders built several kinds of simple eyes. Scallops have rows of small eyes along the edge of the shell. Some tiny animals only sense light and dark. The living world did not invent one eye. It invented many ways to use light. But deep under those designs, there are shared ancient tools. One of the most famous is a control gene often called PAX6. It does not make an eye by itself. That would be too simple. But it helps guide the building of eyes in many animals. The strange thing is that very different creatures use related genetic tools when they build visual systems. This suggests something important. The deep roots of vision are very old. Long before there were human eyes, life already had the basic light-sensing chemistry. Long before there were faces, life already had ways to turn light into a signal. Evolution did not create your eyes from nothing. It kept modifying older parts. That is the way evolution often works. It does not throw away the toolbox. It reuses it. Your eye is not a perfect design made on a clean table. It is a living history. And some of that history is odd. In vertebrates like us, the light-sensing layer is wired in a way that creates a blind spot. There is a place where the nerve leaves the eye. At that spot, you cannot detect light. Most of the time, you do not notice it. Your brain fills in the gap. But the blind spot is real. It is a small reminder that your eye was not built from scratch by an engineer. It was shaped, step by step, from older tissue. An octopus eye does not have the same kind of blind spot. That does not mean the octopus is better in every way. It means its branch solved a similar problem with a different path. Evolution is not one road. It is many roads through time. Some roads lead to compound eyes. Some lead to pinhole eyes. Some lead to camera-like eyes. Some lead to eyes that see colors humans cannot see. Your road led through fish. This is the most important human connection. Your eyes are ancient fish eyes, changed by time. Long before mammals existed, our ancestors lived in water. They had backbones. They had heads. They had paired eyes. Those eyes helped them move through ancient seas. They helped them find food. They helped them avoid being eaten. They helped them keep balance with the world around them. When some descendants of these animals later moved toward land, they did not leave eyes behind. They brought eyes with them. But land changed the job. Water and air bend light differently. An eye that works in water has different problems from an eye that works in air. So eyes changed. The lens, the shape, the focusing system, and the way the eye stayed moist all had to fit a new world. Early land animals had to see through air. They had to keep their eyes from drying out. They had to judge distance on ground, not only in water. Still, the basic inheritance remained. A head, two eyes, a brain reading light, a body moving forward. That ancient pattern continued through reptiles, through early mammals, through small night animals that lived near dinosaurs. For many early mammals, the night was important. They were often small. They were often hunted. Many scientists think early mammals spent much of their lives in dim light. That may be one reason mammal vision changed. Some mammals lost some color vision compared with other animals. Smell and hearing became very important. Our ancestors did not always see the world like modern humans do. They passed through a long night. Then primates changed the story again. Primates lived in trees. Trees are not simple places. Branches cross, leaves hide gaps. Fruit changes color. A wrong jump can be deadly. In that world, vision became powerful again. Forward-facing eyes helped with depth. They helped judge distance before a leap. Color vision helped many primates find ripe fruit and young leaves. It may also have helped them read skin changes in other primates. The details are still studied. But the big idea is clear. For primates, eyes became a way to move, feed, and understand others. Your eyes are part of that primate story. You use them to read faces, to follow hands, to see where someone is looking. A tiny shift in another person's eyes can change what you think they know. That is strange. The same ancient sense that once warned a sea creature about shadows now helps humans share attention. A baby follows a gaze. A friend catches your eye across a room. A crowd turns when one person looks upward. Vision became social. It did not stop being ancient. It gained new jobs. Your eyes still do old things too. They still search for movement. They still notice sudden shadows. They still react to bright light. They still guide your hand before you think about it. If something moves quickly near your face, you blink. That reaction is older than language, older than cities, older than humans. Your body still treats fast movement as important, because for most of animal history, fast movement near the face could mean danger. Modern life feels new. Screens, cars, streetlights, glass buildings, small letters, bright rooms after sunset. But your eyes were not shaped for screens. They were shaped by sunlight, shadows, distance, movement, and survival. This does not make them bad. It makes them ancient. When your eyes follow motion, they are doing an old job. When bright light makes your pupil shrink, your body is protecting a tool that took hundreds of millions of years to shape. When darkness makes you uneasy, part of the reason is simple. Eyes are powerful in light. They are weaker in darkness. A seeing animal becomes more vulnerable when sight is taken away. That feeling has deep roots. The human eye is often described as amazing. It is. But it is not amazing because it is perfect. It is amazing because of where it came from. It came from a world with no faces. It came from cells that could only notice brightness. It passed through cups, shadows, lenses, ancient seas, fish, land animals, night mammals, tree-living primates, and finally, humans. Every time you open your eyes, you are using a system older than humanity, older than mammals, older than dinosaurs, older than forests. A system born when animals first began to use light as information. And once that happened, life could never go back. Because seeing changes everything. A blind world can wait. A seeing world reacts. A blind hunter must bump into food. A seeing hunter can chase. A blind prey animal may only feel attack. A seeing prey animal can flee before contact. Eyes created distance between action and reaction. They gave animals a future. Not a future in the human sense. Not plans. Not dreams. Just a few extra moments. A shadow before the bite. A shape before the collision. A flash before the strike. But sometimes a few moments are enough to survive. That may be the deepest reason eyes matter. They let life respond before touch. They let the body know something from far away. For humans, this became almost invisible because we rely on sight so much. You wake up and open your eyes. The room appears. Objects appear. Faces appear. Words appear. It feels instant. But that instant is built on an ancient chain. Light enters. Cells respond. Nerves carry signals. The brain builds a world. You do not see with your eyes alone. You see with a body that has been shaped to care about light. That is why the story of eyes is not just about an organ. It is about a new kind of life. Before eyes, the world could be touched. After eyes, the world could be watched. Before eyes, danger arrived as contact. After eyes, danger could arrive as a warning. Before eyes, another animal was mostly a smell, a vibration, or a collision. After eyes, another animal became a shape, a target, a threat, a partner, a face. And that brings us back to you. Your eyes are not separate from that ancient ocean. They are the latest version of an old experiment. A light-sensitive patch became a cup. A cup became a camera. A camera became a guide for fish. A guide for fish became a tool for primates. A tool for primates became a human way of knowing the world. You use ancient sea technology to read a message, to avoid a car, to smile back at someone, to look at the moon. That is the strange beauty of evolution. It does not erase the past. It folds the past into the body. So the next time you look into a mirror, remember this. Those eyes looking back at you are not only human. They are older than your species, older than your ancestors on land, older than the first forests. They began as a simple question in ancient water. Is it light or is it dark? From that tiny question came shadows. From shadows came direction. From direction came images. From images came the watching world. And from that watching world came you.